This presentation is about liner shipping connectivity. It's about the structure of the liner shipping network, the shipping network that moves most of the global trade, especially in manufactured goods. The presentation is in three parts. It's about why it matters, why is this important. It's about some trends and characteristics of the liner shipping network. And finally, I will present to you the metrics, the UNCTAD liner shipping connectivity metrics, and a proposal, a bilateral liner shipping connectivity index, which we have developed. Let us start with the first question. Why does it matter? It has been shown that higher liner shipping connectivity leads to lower trade costs. On the screen, you see a chart from a World Bank study, economic premise, where you see the largest red bar is called liner shipping connectivity. It explains a very large part of trade costs as measured by the World Bank and ESCAP in this study. And the measure of liner shipping connectivity that was used in this study was actually UNCTAD's liner shipping connectivity index. The Economist not long ago had an article that was titled "The Humble Hero." The humble hero is the container. It has been shown that containerization has shown to have a stronger impact on trade volumes and trade costs than, for example, joining the GATT or other trade liberalization measures. Other studies have shown that if you have more liner services, more competition, more options, empirically that leads to lower maritime transport costs. Again, another study, specifically on competition in liner shipping, shows it leads to lower freight costs. On this chart here, you see every dot is a freight rate for a pair of country, and at the lower axis you have the number of carriers providing direct service, and you see a quite strong correlation between the number of shipping companies that compete on a route and the freight rate, which is on the left axis. And this impact here, if you look at the correlation coefficient, is twice as high as the impact you see on this next slide, which is distance. So we have the same freight rate on the left, and we have the distance at the bottom, and you see that the previous slide was a stronger correlation. Liner shipping connectivity has a stronger impact on freight costs than, for example, distance. And all this, of course, very much correlate. A lot of this is like the chicken and the egg. If you have more trade, you have more shipping supply, you have more competition, you have lower freight, you have more trade. If you have better services, you have more trade, you have more income to finance infrastructure, you have better services. If you have lower transport costs, you have more trade, you have economies of scale, and you have lower transport costs. So, I trust I've convinced you that this is a very important topic. Now, how can we measure this? What are the trends and characteristics of the liner shipping network? What is the connectivity of countries or of country pairs? Containerization of trade and access to containerized transport services are very important determinants of the country's trade competitiveness. How can we measure this? There are two ways to look at it. One is per country, like in a point. So we have 159 coastal countries in our database, and in this example, we have services by Mediterranean Shipping Company, for example. We could see that, say, Netherlands is clearly better connected than Australia. Australia is better connected than Congo, but by how much? Another one would be per pair of country. You have routes between, say, Belgium and US, or between Cameroon and Tanzania, and so the pairs of countries. And this gets all of a sudden much more complex, and it's exponentially more data in this database. 159 times 158 divided by 2 pairs of countries. Let us start looking at the country level. 159 countries and their position in the liner shipping network. We have the raw data for a liner shipping connectivity index, the LSCI, as an indicator for the supply of liner shipping services. The components of this index are as follows, 5 components. It's on the deployment of the world's container ships. It's all container ships in a database, and we know how many ships, their TEU, their container carrying capacity, the number of shipping companies that compete, that provide services from and to a country's ports, as a level indicator of competition, services, position in the network, and the maximum ship size also as an indicator of infrastructure, the real ship size. We may say we have a very big port and we have dredged a lot, but if the ships don't come, so we have the maximum ship sizes that come and provide services to each country. The raw data is from Lloyd's List Intelligence, continuing a previous CI Online, Containerization International Online, which is where the raw data comes from where we developed the Liner Shipping Connectivity Index since 2004. The calculation is very straightforward. It is indexed, so each component is indexed to be between 0 and 100, and between minimum value and maximum is 100, and then again the average is taken, so that the index generates the value 100 for the country with the highest average index of the 5 components in 2004, which is when we started the index. And the country that generated the highest value in 2004 was China. The data is downloadable, it's online, everybody has access to the index. It's now 11 years, very soon, 2015, we have the 12th year of data, and it's freely available to download the index. To give you some examples, some stories we can already see over the last 10, actually 11 years, between 2004 and 2014 now, the data. For example, China had the highest LSCI in 2004 that we set as 100, and then you see how China's liner shipping connectivity has continued to grow by almost 2/3 since 2004. Hong Kong, China has also grown, not as much. Interesting perhaps to see Korea and Japan started out with practically identical LSCI in 2004, and we see how Korea has grown much more in its level of connectivity than Japan. Another example here, more Southeast Asia. If we compare, for example, Singapore and Malaysia, we see that largely the services go in parallel. Very often ports in neighboring countries are part of the same service, the same structure. So very often you have parallel movements, but at times you also see competition. When one goes down, the other goes up. And you may remember that end of 2006, 2007, Maersk Line switched from Singapore to Malaysian ports for some of their major services. So here we observe this competition. If we move further to the west, we see that India and Sri Lanka have overall similar levels of connectivity, which is interesting, knowing that Sri Lanka is much, much smaller as an economy than India. But here we might see possibly that India has cabotage restrictions, where the feedering to Indian hub ports may have to be done with Indian flagged ships, whereas Sri Lanka, if you feed from Sri Lanka to other Indian ports, then you can use international ships, any flag. If we take now examples from Eastern Africa, we see how Djibouti really moved up, providing above all services of transshipment and also the imports and exports of cargo from and for Ethiopia. Another example here, now moving to West Africa, we see how Ghana, Cote d'Ivoire, Nigeria move very much in parallel. That's the same service that serves the west coast of Africa. And we see how Morocco really moved up tremendously, largely because of Tangier, where you have the big hub port and the transshipment services in Morocco. South America's east coast, we see a rather parallel movement, Brazil, Argentina and Uruguay. Interesting to see how Uruguay, again, much smaller than the other two neighboring countries, and still Uruguay, Montevideo is quite high connectivity as compared, for example, to Venezuela, which has been overtaken by Uruguay. And the last example here, if we take the west coast, South America and Panama, the best connected country in Latin America, thanks to its transshipment port, thanks to the canal. Here we only count the ships that actually call in a port, not only passing through the canal, but still it's a very high connectivity. Hasn't grown very much over the most recent years, and we would certainly expect that with the canal expansion, Panama's connectivity will also grow. If we see Peru and Chile moving ahead of Ecuador, this certainly has to do also with dredging and infrastructure in the main seaports of the three countries. So all these stories over the last 10 years, for any coastal country of the world, you can download the data and produce this type of chart and see the trends over the last, now actually 11 years, 2004 including 2014. And here you have the link stats.unctad.org/LSCI. Some global trends, now looking at the components, and this one could go into more detail and look at for each country, but we don't have the time for this. But just globally, we see that the average per country, we have fewer companies providing services, but more capacity per company. So this is two sides of the same coin, the process of concentration. Fewer companies and more ship cargo carrying capacity per company. By the same token, we have on average more or less the same number of ships that are deployed on services from and to each country, whereas the average ship size has grown very much, practically doubled, if I see this correctly, almost doubled over the last 11 years. So one way to describe this trend, if about 10-15 years ago, or 15 years ago, we reached a peak. In spite of the global process of concentration, the number of companies providing local services had still increased due to the expansion of global players into, at that time, new markets. 20-30 years ago, Evergreen, MSC, and so on, they did not go to all South American, Caribbean, Eastern African markets, and now they are there. So in spite of mergers and acquisitions and process of concentration globally, we actually observed more choice. But today, or since we are observing this data, we observe as the global players are now covering all regions of the world, mergers among them start to lead to a reduction of competition on individual routes. Looking at the routes, at individual pairs of countries. For example, on the route between China and Germany, 2014 data, there were 248 ships deployed with a total container carrying capacity of 2.4 million TEU. The largest ship, 18,270 TEU. 18 companies competing on that route, providing 23 services. So that's the underlying raw data for this example. If you compare this to Myanmar, Myanmar only had 2 direct connections, to Singapore and to Malaysia. So there you see the big difference of being more a country that is connected through feeder ports, or which has its own hub ports and direct services. Indonesia, the largest ship is only 4,800 TEU carrying capacity. That is largely explains also why Indonesia, although being such a big economy, has lower liner shipping connectivity than several of its neighboring countries. By way of example, Tanzania, you see Tanzania and Kenya are very much on the same route. There are 11 companies that provide services to both countries and connect them, but there are also quite a few country pairs like Tanzania to France or Italy or to South Africa, there's actually only one company that deploys ships on direct services. If we look at Panama, we see, for example, the destinations to the west deploy larger ships than destinations to the east. The more than 9,000 TEU ships, they no longer go through the Panama Canal. They only stop on the Pacific coast of Panama. Now, having shown these examples, if you look at direct connectivity, out of the 159 times 158 pairs of countries, how many are connected by direct services? It's about just less than 18%. For the rest, 82%, you need at least one transshipment, and for the large majority, for 2/3 approximately, you can go from A to B with just one transshipment. And you can imagine this a little bit like the tube in London or the metro in Paris, the network. Very often you can go from one station to another with just changing once, because the routes connect sometime in Circle Line or some of the lines. So the pair of country data, it's a bit more complicated than the country level data. We have only about 18% countries connected with direct services, and even those with direct connections, measuring connectivity is not that straightforward. So what I'm now sharing with you are 5 possible ways, actually 6, but 5 ways specifically bilateral that we use as a component to develop a bilateral index. Number 1 is, how many transshipments do I need? To get, e.g. from Argentina to Gabon, I need at least 2 transshipments in the below example. So that's one way. How many transshipments do I need to get from A to B? This is one component that could measure bilateral connectivity. Second one is a position in the network, like how many common connections do I have? This concept is very much like the LinkedIn concept, like how many common connections do I have? For example, Gordon Wilmsmeyer and I, we have 163 shared connections, so that would somehow also illustrate the connectivity between Gordon Wilmsmeyer and Jan Hoffmann. You could use national level data. That is what was done by this example of the World Bank study I mentioned earlier. So you take the geometric average of each country's total connections, for example. The 4th component we are using is the number of companies, and even if there's no direct service, we could then see like how many companies are connecting one country to the hub port, how many are the other, and then in our case we chose to use the minimum, like the minimax. If say Australia, Singapore were 5 companies, Singapore, Myanmar maybe 2, in that case Australia, Myanmar would be 2 in our database. By the same token, we can use the maximum vessel size also to measure like the option to like what is the largest ship on the thinner route where the smaller ships are deployed. So having described these 5 components, out of this that's part of our metrics, the liner shipping connectivity metrics, which includes country level data, the liner shipping connectivity index presented earlier, the individual components of the index. In addition, we have for each country how many partner countries are connected with country A with a direct service. That is also country level data in a sense, because we say for each country how many direct connections do I have with other countries. Then on the bilateral level, we also have in our database the direct maritime distance from the main container port which UNCTAD identified, and then we purchased the maritime distance to the main container port in the other country. For some large countries we looked at different coasts, like United States to Japan we take Los Angeles, Yokohama. For United States to Germany we take New York, Hamburg, for example. We have the information on the direct services, but this is only for 18% of the country pairs. And then we have added what I just described, these components, options to connect with 1 or 2 transshipments, the best way connections by ship size, distance or competition, the number of common connections, and also then the index which we developed, and which we are, the index, there is no problem with copyright with the index, we can share the liner shipping bilateral connectivity index, which we would be happy to share for anybody's use to improve trade models and analysis of global shipping networks. So I've gone through with you why is connectivity important. I've described some trends to you, some global trends, some regional trends, and I've shared with you the data we have available and which we are happy to share for research on liner shipping connectivity. Thank you very much.